Okay, so since I am not here today, what I'm going to do is record the lesson. You guys can either watch this video or you can just read the notes I posted on Google Classroom. And then after that, you guys will have time to work on the homework, which is the Delta Math. Okay, so let's start off with what is symmetry. Symmetry is basically where you are able to fold stuff in half and it be equal on both sides. So what we're going to talk about today is what are lines of symmetry, okay? So, what we're going to start off with is it says identify transformations for symmetry. It says what transformations can be used to map the figure onto itself? Why can some figures be mapped onto themselves? Okay, so the reason behind this is because when we have, why can it be mapped onto itself? It's because we have symmetry. So if you guys remember the practice check, that question about the square, a square is equal on all four sides, so therefore it can be symmetric to itself. So what we're going to talk about is what's known as the first type of symmetry is called reflectional symmetry. Okay. Which is basically how it sounds, okay? It's basically the symmetry in which a reflection maps it onto itself. This line, the line that we map it, the line of reflection, is what's called, for reflection, okay, is called the line of symmetry. So if you notice in the pictures below, your line of symmetry is like that M and the N line, and we know that we can fold it in half and it'll be equal on both sides. So that's the first type of symmetry, reflectional symmetry, okay? And then there's also another type, so we can also talk about rotating an object, which is known as rotational symmetry. Now this one's a little harder to see, so let me explain it through with a picture, but let me write that down. So rotational symmetry, okay? It's basically like if you are mapping it onto itself. So like imagine rotating this around, okay? This point here is getting rotated around and you're seeing how many times can it map onto itself. Okay, when we're talking about rotational symmetry, the biggest thing is it has to be less than 360 degrees, okay? So it cannot be greater than 360 because all the way around, okay, would equal 360 degrees, okay? And we'll practice a couple of those looking at the rotational symmetry, yeah, okay? So if we're looking at this shape really quick, the one thing it says the rotational symmetry maps onto itself. It's because if you drag it this way, it lands on itself here, and then it lands on itself here. So it's broken down to 2 halves, which is 180. Okay. Okay, so let's just start with identifying the lines of symmetry. So this is going to be talking about reflectional symmetry, which is basically if I could fold it, how many times does it fold on itself? Okay, so the easiest way to start this is starting with the corners. So if I fold it here, that would be one way. If I fold it here, that would be a second way. And if I fold it here, there would be a third way. Okay, so automatically there's 3 lines of symmetry. And then from there, you can also go in the middle. So if I fold it in the middle here, that would be one line. You fold it in the middle here, that would be another line. And then finally, the third line would be here. So in other words, it's asking how many lines of symmetry does this regular hexagon have? That would be just a total of 6. You're just counting up the amount. Okay. That's how you do it. All right, really quick, pause this video, okay, and try these two to determine how many lines of symmetry. Pause it now. Okay, so to check your answers, we're just drawing in the lines of symmetry. So for a rectangle, be careful. You can't draw it like diagonal because it's not going to land on itself. So the only 2 ways would be here and then here. So there would be 2, okay. And then for a trapezoid, the only possible way would be here, because if you map it this way, it wouldn't land on itself. So that would just be 1. Yeah. Okay. Okay, so the next part is we're going to talk about is what's referred to as the order and how it relates to rotational symmetry. Okay, so let's talk about this, okay? What we're going to refer to this is, it's going to be called the order, like in Star Wars. Okay, so the order of rotational symmetry that an object has is the number of times that it fits onto itself during a full rotation of 360 degrees. So here's what we're going to do is we are going to start off with an equilateral triangle. So here's how you need to imagine it. You imagine like essentially rotating this object around. And I might post a link to show you guys like a demonstration of that. So if you want, you can do that. Okay, so essentially, if I'm rotating that equilateral triangle, which means it's equal on all sides, I rotate this point around this way, it will land on it once. This way would land on it twice. And then finally, all the way around, you would land on it 3 times. So the order, okay, would be 3. Okay, yeah. Yeah. All right, let's try the next one. So a parallelogram, okay? You're imagining, I would just take a point in the corner, and you're imagining rotating it around. So here it wouldn't land because it would almost be standing up, but then over here, it would be 1 point there, and then finally all the way over. So in other words, there would be, the order is 2. Okay. One other thing that I need to cover, okay, is talking about angle of rotational symmetry. So how to find the angle of rotational symmetry. Okay, is like this, okay? If you're rotating all the way around, that's 360 degrees. And then what you're going to do is you're going to divide it by n, and n is going to be the order. Okay, so in other words, let's just add a part onto this. Okay, so you would get for the angle for this first one, you just do 360 divided by the order, which is 3, and so you get 120 degrees. That's the angle. Okay, and it's degrees because we're talking about an angle. Versus here, the angle 360 divided by 2, and so you get 180. Is the angle of rotational symmetry. Okay. Okay. All right. Finally, the last type, it says the type of symmetry for which there is a rotation of 180 degrees that maps the figure onto itself is called point symmetry. Okay, so essentially it's what I just did above. You're taking like the amount of points that occur between like 0 and 360, and yeah, it's just point symmetry. Okay. Okay, so if you want to pause the video and answer these 4 questions, and then once you restart the video, I'll go through them. Okay, so it says, what are the rotational symmetries for each figure, and does this figure have point symmetry? Okay, so the first thing is, when we're talking about rotational symmetries, we're really talking about the order. Okay, so in the first one, your order, if you take this point and move it kind of around, it lands on it once, twice, 3 times, 4 times, so your order is 4. Okay? And then it's asking, does this figure have point symmetry? Point symmetry means it's symmetric when you hit those points. So in other words, I was rotating around using those points, so this would be yes. Okay. Next one. All right, so the order, I would take like a point over here and kind of move it around. It would land on itself once here at that point, and then twice, so the order is 2. And then it's asking, does it have point symmetry? Again, it's because like it's symmetric on the points. This would be yes. Okay, I'll show you one where it would be no. Okay. Number 3, the order would be 4. So you're doing 1, 2, 3, 4. Okay. And so point symmetry, that would be a yes, because you're taking the points, and they would be symmetric on the points. Okay. All right, let's look at this one really quick. So this one, if you notice, it kind of has like curved edges. So here's what I would do is you're kind of moving this arrow around. So it'd be like once here, then twice, then a third time up here. So the order would be 3, okay? But with point symmetry, that's where it's going to change, okay? When you're talking about rotating, you're not rotating a single point. You're rotating this entire object, which means that it's not like a single point. So this would have, no, it would not have point symmetry. So like versus the other ones, you're just rotating a single point around and it lands on itself. Yeah. Okay. Oh yeah, so that's it for the lesson. So your homework that's going to be due tomorrow is going to be the Delta Math. It's going to be labeled 3.5, lesson 3.5, and that's it for the test. So our test will be on Wednesday. You guys can sign off now. Okay, bye.